Okay, guys, last day of Unit 2B. So this is inverse functions continued. We're going to start off by giving the inverse of this function here. F at x is equal to 2x squared plus 16x plus 29. And like I did in class, what you need to do is we need to replace x with y and y with x. And if we do that, you're going to end up all messed up because there's too many y's here and squares and that sort of thing. So what you have to do first is complete the square and rewrite this in. We need this in vertex form. So I need this in vertex form. And to do that, I complete the square. And remember how to complete the square. You factor out the a, and you're left with this. Remember the 29 goes way over here. And then I want plus and minus half of, I do agree. Thank you. Oh, great. 22 microns, John, you agrees. That's horrible. Okay, so here we go. Plus 8x plus 4, half of this squared, add it and subtract it. Plus 29. This becomes this. These terms here turn into x plus 4 all squared. Where does the 4 come from? Right here. So that goes there. Subtract 16, which is 4 squared. So square bracket here, plus 29. Next up, 2x plus 4 all squared minus 32 plus 29. And finish it up with this. Minus 3. So then that's that. What's my vertex? If I was to sketch this, here's my vertex, minus 4, and then minus 3. You'd plot that over here somewhere. Minus 4, minus 3. It would look like this. And then I'm going to apply the transformation now to, not transformation, I'm going to change this now to a, find the inverse of this, sorry. Swap the x's with the y's. And it is going to, remember what that is, inverse is a reflection on the line x equals y. So this point, negative 4, negative 3, becomes the vertex of my new point, which is negative 4, negative 3, negative 4. So negative 3, negative 4 be somewhere like this. And I end up with something that looks like this. So you can always sketch these on Desmos to figure out what it looks like. But we won't in this case. What we'll just do is find the equation for this. Okay, so isolating, moving things around. I'll do this a lot quicker. That's plus 3. Then what I was doing, so that's going to be gone. And then what I was doing today in class was instead of dividing by 2, I was multiplying by a half on each side. That way, you'll see in a second, that way I'll have k here instead of having something divided by 2. So that gets rid of this. And then what I want to do is unsquare this, which is that. Unsquare that. I've never said that before. But anyway, that looks like that. Sorry, that was a half times all that. And then I end up with unsquaring it, and I end up with a minus 4 I get rid of. So that looks like this. Okay, so that is my new function. And again, I have a root sign, which is based at negative 3, negative 4, transform 3 to the left and down 4. And that's what I had here, right? And I want both sides, the plus and the minus, so I have a plus and a minus here. So the reflection part gets me that. Okay, and if you look here, now with a half here, it's k isolated away from x plus 3. So k is out of the bracket, and that's where I wanted it in the first place. Okay, so that's that. You keep going, and we talk about the second part of the last section of the course is talking about restricting the domain of a function, of a parabola, sorry, so that its inverse is itself a function. So if I had this, and then I went ahead, so this is to the left a bit, so the equivalent will be down a bit. And then I have this as my inverse, right? Their reflection on the x versus or x equals y line. That's a vertical line test. Passes the vertical line test everywhere you go. This guy fails right away. Okay, so not a function over here. So what you're going to end up doing, what you need to do is you need to restrict this so that this becomes a function. If you want this to be a function, what you need to do is chop one of these arms off. So what we do is we don't include this arm. So we're left with what's here. And that's a function. But then I can't say that this is the inverse of this without an arm. So what you have to do is chop this arm off. Okay, and how you do that is by restricting the domain and the range. So very simply, if I had something like this, let's just pretend that I had an equation and I ended up with something like this, and I had a vertex of, that looks maybe like 1, 7. And I wanted to chop the arm off so that when I go to 7, 1 here and have my inverse, that I only end up with the top part. Well, if I want this part here, this right part of the arm goes with the top part of the arm. And you can think of it this way. this is getting very positive in the x. This gets more positive in the x coordinate, and then that means its inverse gets more positive in the y coordinate. So that's why this arm goes with that. So you need to chop this off here. So originally the domain of my parabola was x is a real number, but when I chop this arm off, what I'm doing is I'm saying I only want what's over here, so I only want what's greater than 1. Okay, so you take this value here and you say, just give me this stuff here. And when you cut that off there, that changes the range of the inverse to be y is a real number. Y is greater than or equal to 1. Okay, so you cut off the left arm, which cuts off the bottom arm of the inverse, and then you have a function. Okay, so let's do that from start to finish with an example that we did in class. Let's go to this one right here. Okay, so that guy looks something like this. This is already vertex form, so -1, -4, and it looks something like this. Okay, so that's my original parabola. And so -1, -4 is my vertex. When I get the inverse, I would have a vertex of -4, -1. So somewhere around here, I'd have this like this. Okay, but I don't want the sideways parabola because it's not a function. So what I'm going to do is chop this guy off. And to do that, I need to restrict my domain. So what is my domain? How would I restrict my domain? Well, x is a real number. This is for f at x, the upward pointing one. And I want to cut this arm off here, so I only want values of x that are greater than or equal to -1. Okay, so this is at -1. I only want these guys, so I want x greater than or equal to -1. And then that, when I look over here at the inverse now, then I'm going to have a range that includes only y values that are greater than -1. Okay, because the domain of the function is the range of the inverse and vice versa. All right. The only other thing we did in class was after this fact, and we just did this previously. I'll do it real quickly, but then we said find the equation for this, the inverse of this. And for that, you just rearrange. So that becomes 3y plus 1 all squared minus 4. And then you go through it and solve for y. And you end up with this. You go ahead and do that on your own. But you end up with x plus 4. X plus 4 divided by 3. X plus 4 times 1/3 here. And the whole thing has what is -1. That's -1. So you end up with, that's your function inverse equation. Okay, and don't forget that's how you represent the inverse. And that's it. A little sloppy today, but hopefully it made sense. And that's it for the unit. Test covers all transformations and everything about inverses, 2 days of inverses. And that should be it. Enjoy and have a nice, safe weekend. And thanks.